Hey guys, so sorry I went off on a massive tangent on the last one. If you're skipping that video, that's totally fine. What I've done is I've separated out what we had before into a new file. If you've continued on before, that's fine. Just remember that everything's going to basically, from this point on, be a different function or procedure in our menu. So what we had before was our encryption. And that was taking our value and changing it into the equivalent in here. So A would become C, B would become X, and C would become V, and so on. And then we print it out. So we want to be able to go the other way as well. And to do that, that's going to be D. So when we decrypt, we want to go backwards. Now, that's actually not as easy as going forwards. So we're going to have to be using an algorithm here called a linear search, which we'll get to in a second. So anyway, we're going to take our cipher. Now again, let's make a little thing above just that we can work with, so that we can get an idea of what's going on. So let's say our cipher is, well, in fact, let's make one. So A, B, C, D becomes C, X, V, E. So C, X, V, E is my cipher. Now, I want to take the first character of that cipher. Now, again, Python has nicer ways to do this, but for me, and for IGCSE, we're going to do for X in range 0 to the length of the cipher. Okay, and then what we're going to get from that is the cipher. Now, these are terrible variable names, but character, okay? The psi character. That sounds kind of cool. So, psi character is going to be equal to the cipher at position X. Oops, cipher at position X. Okay, so this is our cipher. So CY character, let's maybe just write it here. Cipher equals. So that means that CY character is going to equal, first time, is going to equal C. Okay, now what I have to then do is look up the cipher character in my key. So I'm going to have to go through every character in here and find which position is that letter in. So for example, C is in position 0. B is in position 0, 1, 2, 3, 4, 5, 6, 7, is in position 7. And that's called our index. Okay, so let's call that our CY index. Now, how do we get that? Well, we're going to have to use a little algorithm called a linear search. And that's going to involve a second for loop. So we can't use X this time because we've used X already. So let's use Y this time. So for Y in range, and we're going to start at 0. And we're going to go until the end of this. So 0 until the length of the key. And I'm going to say if the character equals the key at position Y, then we've found it. So then I can say that the CY index is equal to Y. Okay, so that means that C is 0, so the CY index would be 0. If I looked up, if I looked up E, E would be 0, 1, 2, 3. Okay, so the CY index would then become equal to that. So C is, as we said, is 0, so it's going to be in position 0. So I probably shouldn't have started with C, but still, go with it. Okay, now that I've got its index, I need to change it back to the Unicode. Now, again, we're not dealing with Unicode today, so you're going to have to deal with that if you've no idea what Unicode and ASCII are. But we already said that 97 is the Unicode for the first letter, which is a small a. So if I wanted to change the index to be the Unicode, I would then have to add. So once I've gone through it all, I could add a break in here. I'm not going to add a break. So once I've found it all, I can then say that the CY Unicode is going to be equal to the index that I found it at. Now this is making a massive assumption that I found whatever they've entered, but okay, we can deal with that later. Plus 97. So C is 0, so plus 97 should then become equal to an A. So the CY Unicode is going to be equal to 97. And that means that my plain text character is going to equal an A. So how do I convert from the plain text character Well, I use CHR and I put in the Unicode value into that. Okay, now that's only for one letter, so I then have to remember to append that to my, I could use plain text, I'm just going to call it new plain text, just so that my code doesn't get messed up. So I'm going to call it new PT equals new plain text plus the new character that I have found. Now, fingers crossed, if I then print my new plain text, and this is a very fingers crossed, it should then give me what the original cipher that was printed above it is. Okay, so let's see. So A, B, C, X, Y, Z. So again, it's always good to check the boundaries. Oh, new PT is not defined. That's not good. Okay, so here I've said new PT equals new PT, and there isn't anything called new PT. So it's going to cause an error there. So that was bad on my part. So before we run anything, we should say new PT equals nothing. Okay, let's try again. Now, again, don't worry about errors. There's nothing wrong with getting errors in code. That's just how we learn stuff. And it's one of the good things about computers is that we can run stuff again and again and again. It doesn't matter. Anyway, so our cipher is going to be the same as before, but then when I decrypt it, it's converting it back into the original message. Yay, big success. All right, so that's our decrypt.